Okay, this is a good little example. This is example, well, it's not an example, it's a homework problem. It's homework problem 6-126. Okay, so what you have here is you have this press, which is used to emboss a seal, a small seal at E. Okay, so you know that P is 250, so this is 2. You know that P is 250 newtons, and when you push down on this, just hopefully you recognize it's going to push a force down this direction, which is going to end up squishing this into there. Okay, so now how do we do it? Well, like all problems, let's start with the free body diagram. I'm going to look at this member right here, right? So I'm just going to look at this member. So let's draw that member. Okay, now at point A, I have a force, unknown force this direction and this direction. I'm going to call that AY, AX, right? Here, I have an unknown force, but it's not in two directions. This is, what do we know about this one right here? This is a two-force member, so therefore, oops, sorry, we know the direction. It's off in, stop that, in that direction. We'll call that B. Then here at P, we have 250 newtons going down. Okay, so let's take the sum of the moments. Do the sum of the moments, and I'm going to do them at A, just because it makes life easy. So at A, what do we have? Well, this force, really at B, what do we have? We have two components. We have a vertical and a horizontal component. Now I drew this backwards, and not really on purpose, but we know that this point right here is going to be feeling force in this direction, right? It's going to cause a force on this member. This member is going to get compressed, and so in return, it's going to push back. So I'm going to fix that right here. Oops, well, that was not what I meant, but it'll work. So you have a force in this direction at point B. Okay, so I can call just B, Y, and BX. Okay, so when we look at our sum of our moments at A, let's do it here. Sum of the moments at A equals 0. So what do we have? You have BY times this distance. Well, this distance, in this case, we're talking the vertical component of it, so we're looking at this distance, and that distance is 200 times the sine, no, that's cosine, sorry, cosine of 60, right? And that's going to make it want to rotate in this direction. And I'm going to say plus by times, now this one, sorry, bx. And this now is going to be times this distance here, right, which is 200 sine 60. And it's also going to want to make it rotate in that direction, so it adds together. And that needs to be equal to, there's only one force going in the other direction, that's 250 times the distance from here all the way to here. So what is that? That is that's this distance, which is 400 cosine of 15 plus 200 cosine of 60. Sorry, that got really ugly. Okay, so we have right now really only two unknowns, by and bx, but we know their relation. And how do we know the relation? Well, we know it's a two-force member, and it's at an angle of 20 degrees, right? So our x and our y, our bx is going to be simply b times sine of 20, and our by is going to be b cosine of 20. Okay, so let's replace those. So our by, I'm going to put b times cosine of 20 times 200 cosine of 60 plus bx, which is b sine 20 times 200 sine 60 is equal to, and this number over here ends up being 46.4 times 250 is 121,600. Okay, just because I ran out of space, and it's just a number. It's just a whole bunch of constants, so it's a number. So then we can just simply solve for b. So b is, it gives you 793.64. Okay, so is that the answer that we're looking for? No, it is not. Because why not? It says, well, we're looking for the vertical component of the force exerted on the seal and the reaction at A. So basically, big picture, you're doing this, and the question is, okay, is this going to push down hard enough to actually make the imprint? And are we going to tear A out of the ground because we're pushing too hard? Those are the two things that we're considering. Well, we now know B. So what do we know? At that this member, I'm going to clean this up a little bit. This member right here is experiencing a force from the other one of 793.64. So therefore, at this point, it's pushing back with the same force. And so how much of it is the vertical component? Well, if you look at point D, if you just do sum of the forces in Y, you find out that the dy is equal to by, which is just b times cosine of 20. And so therefore, dy is 746 newtons. So that is a vertical component of the force acting here, which is going to cause the embossment of the seal. Okay, so that's part A, right? So we're by pushing down with 250 newtons over here, we have a net effect of pushing down to 746 newtons there. But then the question is hey, are we going to start tearing this thing, out of the ground? Is that design strong enough? So how do we do that? Well, that's just a simple sum of the forces in X equals 0, sum of the forces in Y equals 0. So let's do sum of the forces in X. So what do you have? Well, there's only, if you look at our free body diagram, right, back to the free body diagram, there's only two X forces. I have AX equals BX. And we know that BX from right here is equal to B times sine 20. So AX is 271. And then we'll do the sum of the forces in Y. Sum of the forces in Y equals 0. Now we have three forces in Y. We have this AY, and this BY, and this 250. So I drew it as a force up, but we will find I'm going to be consistent with what I drew. So therefore, AY plus BY equals 250, right? So AY equals 250 minus BY. But BY is, well, it's this right there, right? So it's equal to 250 minus 746. So AY is a negative 496. Or AY is 496 in that direction. Now, this thing is trying to be, when you're doing this by pushing down over here, it's pivoting on this point, and this is trying to come up, and so you have to hold it down, so the reaction is down. So there you go. So we're putting 746 newtons of force on the seal, and our A is being pulled apart by 271 newtons in the lateral direction and 496 in the vertical direction.